I know where there's some, right here in the hall, clerk.
No, Molly, not in there. I have
So here it is back under the microscope, and we're looking at the two ends of the one broken wire that I can see. There may be more. The one on the right is accessible, but the one on the left, the one I'm pointing to, is covered by the wire that's connected to that terminal right there. And so what I need to do, I think, next is unsolder, remove all the solder from that point right there, and see if I can lift the wire and release some tension on or remove the covering from the broken one, so I can see if I can scrape enough away to solder a bridge between the two broken ends. So we'll see if that's possible. The wire that's used in this was created, first of all, by Edward Weston, the same guy who did the improvements on the Doris and Fall movement and went on to build the Western Instrument Company. In 1887, Weston discovered that a certain alloy, called alloy number 2, would have several other thermal stable properties. But one of them was that it would have a certain resistance per length. And it's an alloy containing copper, ferromanganese, and nickel. It was produced in Germany, where it was named Constantan. In the United States, it was referred to as Manganin or Manganin. I don't know which is correct. But again, we owe this metal to Edward Weston. Yeah, this is the end of the wire right here. And I don't know if you can see it or not, but yeah, there's the wire. And that's what's wrapped around this piece of copper here. This is tin copper. So our break is right here is the longish lead, and the short one is right there. Okay, I've tried to patch this. I have some 38 gauge wire, magnetic wire, that I have attempted to solder onto the two leads that I have exposed here of the broken out. Well, I could see the one broken out place in here, and it didn't work. Bottom line is it didn't work. Still have an open resistor here. So I'm kind of stuck with rewinding it. So let's talk about what I'm going to rewind it with. As I said earlier, the original wire on here is probably something called Manganin or something like that, developed by Weston. I don't know. I can't find any. This isn't manufactured in the United States anymore, as far as I can tell. I shouldn't say that. There are a couple of companies that will make this stuff up, but it's used in strain gauges and things like that. So this isn't very common. I certainly couldn't order a spool of it anywhere I looked in this gauge, and I'm guessing the gauge is around 36, 38. So poking around eBay, I did find another source. As I said, this is Constantan wire, and this originally was made in Russia, and there's a whole bunch of it being sold by a Ukrainian company now. But here's the critical bit. This is its diameter, 0.1 millimeters. This is the critical bit right here, 62 ohms per meter. It doesn't say per meter, but it did in its documentation. So what do we need? We need 1,270 ohms. And this is 62 ohms per meter. Divide 1,270 by 62, and you come up with 20.483 meters. So I've got 50 here. I can screw this up once before I have to order some more. So I'm going to try to rewind this bobbin and see if I can get almost 20.5 meters on here. It should be possible. The size isn't, as I said, this appears to me to be about 38, 36, around in there, gauge wire, AWG, and this is about the same. So, and it's insulated with cloth. It just happens to be blue instead of beige. So I'll try that. Oh, by the way, this is not Manganin or Manganin wire. This is Constantan wire from Europe. Slightly different formulation, slightly different alloy than this one, but it's available. This one is not available. Well, I should say one other thing, historical factoid about this that I found out was that this wire, the U.S. Bureau of Standards used Manganin wire resistors as the legal standard for the ohm from 1901 to 1990. So that wire has been around for a while, since Weston's day. Anyway, to start rewinding this coil, I need to measure how much of this 62 ohms per meter wire I need. And I decided to use this PLA spool from my 3D printing, empty spool, obviously. So I measured the circumference using a string and a pen, and the circumference turned out to be 30.4 centimeters. And then I did a little spreadsheet for myself. I desire 1,270 ohms, 62 ohms per meter. That gives me a target meter length, or target length in meters, of 20.483 meters. In centimeters, that's 2,048.387 centimeters. The drum circumference is 30.4, therefore I need 67.38 wraps around this spool. According to that, 67 wraps around this spool will give me the resistance I need. I'll probably do 70 and then back up from there as I measure it. So I had to center this spool, so I printed a couple of hubs on here, and then acquired this cheap winder, and that will fit right on there. Pardon the noise. And I'll tape the end of the wire in here, leaving myself a fair amount of room, and I'll just hand wind it on here for a total of 68 turns, I think, on this counter. So that shouldn't be too hard. It should work. The only thing I'm nervous about is how fragile this wire is, whether it has any tensile strength at all, whether it'll take some strain or whether it'll just break right away. Pretty narrow gauge. On the other end, it feels pretty strong. So we'll see how it goes. That'll be my... Okay, there's 70 turns. Should give us ample to cut it back to the resistance we need. This is remarkably strong wire. As thin as it isn't nearly as fragile as plain copper magnetic wire. So I'm very pleased with that. Okay, now I have to get this off this spool and onto this spool. If you happen to work with this stuff, be aware that it has not only does it have a cloth wrapper around it, but the wire itself has some kind of protective. It doesn't look like varnish, but it might be some kind of varnish. Anyway, you have to remove that layer with either some emery cloth or I tried just a moment of heat from my butane torch thing, and it flares off really quickly, and the wire seems as strong as it did before. Be aware too that you can, if you hold this on there too long, it will destroy the wire. But now that we have these two ends, let's see if I've cleared the insulation off. Let's see if we've got the resistance I'm hoping for here. We need it to be over 1,270 ohms. So let's see if we've achieved our goal. Okay, we've got 1,579. So we went over as I was hoping for. I think this is going to work. And it doesn't look like I can have much trouble getting all that wire onto this spool. So that's next. Okay, we've got the spool cleaned off. And here's the wire that came off of it. I found 4 or 5 breaks. Green ends. In fact, I can see one right there where it is starting to corrode. But yeah, this was never going to be fixed. So I'll pitch this and we'll start putting this stuff on this spool. And there we are, a fully wound spool of wire. Now I'll strip the ends. This one is one end, the other is wrapped around this post here. I'll strip those and we'll go backward until we reach our target resistance. Okay, I'm very close. I'm down to 1,282 ohms. I need 1,270. What I found is it's about 2 ohms per inch if you're doing SAE measuring. So I've got about 10 ohms to go, which would be about 5 inches. So I'll take 5 inches off here and see where we are then. I'll take 4 actually. I really appreciate how strong this stuff is. Not nearly as fragile as pure copper wire of a similar size. Okay, I've got them soldered down, and I put the ohm meter on there. Let's see how close we got to 1270 ohms. Ah! Took too much wire off by a 1/4 inch or something like that. A couple of mils off in the wrong way. Oh well. So we've got a 268 ohm resistor instead of a 270 ohm resistor. Given that this is never going to be a laboratory instrument, I think that'll be okay. So next, this all goes back into the meter, and we'll see if it works okay. Okay, I have it mounted back where it belongs, pardon me. And now we'll check the resistance one last time. To make sure I didn't open up anything here. 1,267 ohms in circuit, 267, 268. Our target was 1,270, so we're within 3 ohms. That's just going to have to do. And here it is, back in its home. I've got the bumpers back in. This one needs to be right at 0, and that's as close as I can get it. I cleaned this up with water and a little mild soap. Had some dirt up in here. It looks pretty good now. So I think this is done. It's we have our multiplier resistor back in place, and I will set this aside someplace safe and clean up the housing it goes into and put it back so that it has less chance of being dinged up. That's my goal, is to not ding this up. Okay, that's it for the meter. Next we'll see what needs to be done in the chassis.